Hello, YouTube. Welcome back. What are we doing today? C4X3, the ice cream cone tester. Well, ice cream cone class and the ice cream cone tester class. Okay, so let's see what's involved with that. Alrighty, so what we'll do is we'll cd to the YouTube. Whoops. We'll cd to the YouTube directory. And we have C4X1 and C4X18. I skipped C4X357, by the way, but all right. So mk directory, make directory, C4X3. cd C4X3, and let's get an editor, an ASCII editor, new file. Okay, so why don't we call this one ice cream cone tester. Let's start with the tester. Ice cream cone tester. Okay, so ice cream cone tester.java. All right, good. And your name and the date. Now, we did this some time ago, but today is, what is today? Today is the 17th of November. Okay. I think we did this at the end of October, actually, but whatever. All right, let's save this. Let's see, can I copy this? At least, alrighty. So let's save it, Control S. All right, so I want to be in the YouTube folder, and then I want to be in C4X3. Here it is. And let's see, save, put it there, and enter. No. What can I save it? Control S. There you go. Control V. Good. And let's go down to C4X3. Am I in there? Yes. And save. Ta-da! Alrighty. Okay, that should do it. Alrighty. Oh, I didn't save it properly, did I? Ugh. Let's try that again. Control S. No. What did I do? I can't get over here. Can I get over here? There you go. What happened there? In C4X3. I think I didn't call it .java, did I? Dang it. All right, can I delete that? Yes. Okay, let's start over. New file. All right, so C4X3, where are you? There you are. Save. There you go. Perfect. All right, so purpose. Find the surface area and the volume of an ice cream cone. Now, we're talking about the lateral surface area, not the circular base. Just the sides, like the waffle cone, how much waffle cone can you eat? And the volume, how much ice cream can you eat inside the cone, not above the circular base, again. But whatever. So purpose. Find surface area and volume of my ice cream cone. Let's see here, just a minute. There you go, perfect. Oh, I didn't put the slash over here. Very nice. Okay, required files. Required files. This file. And the derived class. Okay. All right, translator phase. Just Java C tester. Interpreter phase. Whoops. Okay, Java the class file. Java bytecode file, right? But you know what? We're going to do args input for the radius of the base of the cone and the height of the cone. How about that? Okay, and that's that. All right. Now we're going to be using the math class, the static math class, but we don't have to import it because it's automatically imported in java.lang. Let's take a look at that. If we go to the Java API, what just happened there? Hang on, let's get back there. Okay, so packages. All right, so we go into the java.lang, which is everything that's automatically imported. Okay, and then go to the classes, and we're looking for the math class. There it is. You'll see that you have such things as, let's see, what did we use in here? We used, didn't we use Math.POw? Yes, we did, and Math.sqrt. Math.PI. Okay, good. So let's take a look at that. So here we go. Let's go down into the documentation here. Okay, so there's some static, public static doubles that can use Math.PI. Notice it's a static class, so you don't have to, construct a math object. So instead of, math Bob equals new math, and then Bob.squirt, you just do Math.squirt. And in this case, Math.PI. Okay, so I'm going to use Math.PI in here somewhere. And then there's Math.absolute value, Math.sign, all this fun stuff. Math.seal, Math.floor. We'll talk about that. So I think primarily we need Math.squirt and Math.pow in here. Let's see, SQRT, there it is. Returns correctly rounded positive square root of a double value. And Math.pow, did we see pow yet? Math.pow returns the value of the first argument raised to the power of the second argument. Okay, so that's what we're going to be using. Alrighty, so here's your main class. Public class IceCreamCone tester. All right, public static void main string array args. We're going to use that for input today. Okay. All right, and there what we're going to do is we're going to capture the input. We're going to say double, declare double for the radius equals double dot parse double arg0. There you go. And double h equals double, the double wrapper class, right? Dot parse double, so we can make sense of the string that's really a double. Args1. Args, string array args of 1. And so let's construct an ice cream cone object based on that input. Ice cream cone foo equals new ice. Do I still have ice cream cone in here? Yes. Ice cream cone plug in r comma and h, r comma h. Boom. All right, good. And then for fun, let's do some accessors, get r and get h, to make sure the constructor worked out correctly. System dot out dot println what? Now let's keep it simple. R equals concatenate foo dot get r plus quote inches. How about that for inches? Okay, good. And same thing. The same thing here. System dot out dot println string h concatenate foo dot get h. No input parameters there. Whoops, what happened to my equal sign? Equals. And that's going to be in square inches because it's a surface. No, I'm thinking ahead of the surface area, and cubic inches for volume, but this is just inches for the height. Okay. Plus inches plus string inches. There you go. That's it. So done with the main method and done with the main class for the moment. Now we still have to do some more accessors to calculate the volume of the surface area, but let's get this much working. All right, so save it, Control S. All right, let's make another file. This one, I'm just going to do a single line comment, ice cream cone. Whoops, I have a cone. All right, and your name and the date. And let's save it. All right, so I want to save it in the YouTube folder and then down C4X3. I should probably put these in separate folders for Lab 4, Lab 3, Lab 2, right? What have you. Okay, there it is. And save. Oopsie, I didn't title it. How do you... File. Save as. Ice cream cone. There you go. All right, so save that. Right there. All right, perfect. All righty. I wonder, wait, what if... Oh, let's not fiddle with that right now. All right, so... All right, so public class. Oh, I did it again, didn't I? Unbelievable. File, save as, ice cream cone. .java. It's been a long week. All right, so now I'm going to have an untitled, I'm going to have ice cream cone and ice cream cone.java. All right, we'll ignore everybody else, but what we need. Okay, so ice cream cone, not tester. All right, so let's write the constructor, public or not, public. Void or not, neither, ice cream cone. But there's a parameter list, double R and double H. Notice the order matters. We're inputting R and H from the client class in that order. All right. And all we're going to do is, how about a this dot? Yeah, we're going to do this dot. R equals R and this dot H equals H. All right, so that means I need some private instance fields up here. Public or not, private. Void or not, double. And it's going to be R. And public or not, private. Void or not, double. And it's going to be H. And then let's do the accessors. All right, so get R, public or not, public. Void or not, double. Returns a double. Get H. No input parameter list. Okay, and we're just going to return h. Alrighty. And let's also do get. Let's move this up a little bit. Okay, so get r. So public or not, public. Void or not, double. Get r. And what we're going to do is return r. The other two accessors, you can do return like an expression or a calculation. So we'll get to that. All right, so save that. And let's test it. And as you can see, we have some files we don't want. We have IceCreamCone.java and IceCreamCone.tester.java. Let's get rid of IceCreamCone. Not .java, just IceCreamCone. And untitled. RM for remove file. Untitled. Yes. Okay, good. So Java C, IceCreamCone tester.java. Oh, what'd I do? Oh, I'm missing a semicolon or something there. Oh, I didn't close the parentheses on print line on 20. What the heck happened there? All right, let's go. That's the tester, right? All right, line 20. Oh, yeah, what am I doing? Okay, put a little close parentheses there for the print line, a semicolon for the command line. Save it. All right, let's see what else we did wrong. It's been a long day. I didn't close the class or something? What happened? I thought I did. So was it line 23? Okay, let's take a look at line 23 in the tester. So down here. Oh, I have too many clauses. What I have. Hang on. What's the bottom of the file? Okay. Yeah, that's better, right? We have an open and close for the class. Open and close for the main. Okay, save it. That's what I was just screencasting late at night. Not good. What do I do now? Missing body. Oh, why did I put a semicolon on that line? Line 7 in the derived class. What are you doing? Yeah, no, wrong. This is like a new mistake I keep on telling my kids not to do. All right, save it. All right, time to Java it. Let's put in, I don't know, 2 and 5. So 2 is the radius and 5 is the height. And boom, boom. Okay, so R is 2 inches and H is 5 inches. R is the radius, H is the height. Perfect. That much is perfect. Okay, so now let's do get volume. The volume of a cone is 1/3 pi r cubed h. So we figured out in class how to write that. All right, let's do that. Let's add something to our tester here. How about system.out.println. Okay, so quote v equals quote plus foo dot get v. How's that? All right, save that. And let's write get v. So let's put that down here. Let's go to the bottom. All right, so right there. All right, so get v, public or not, public. Void or not, this is also an accessor, right? So it returns a double. All these numbers are doubles. Get v, no input parameter list. All right, so we're going to return. Okay, so what is it now? Pi r squared h over 3. How about that? Okay, so Math.PI. Notice it's capitals, uppercase, for finals or constants, times Math.pow, pi r squared, right? Math.pow of r comma 2 r squared. Okay. That's it. Good. Times h over 3. Perfecto. And all this stuff is double, so that 3 doesn't really give you an int when you divide by 3. It's a relative divide. All right, save that, and let's run that. And we get 20.944-ish cubic units. Oh, we should put cubic units in the output. And I think that's what we got in class, so that's good. All right, we tested that in class with the TID4. How about plus, quote, why won't it plus? Plus, quote, inches, cubic inches, inches to the third. How's that? Save that, test that. And there you go. If you want to space out, the units, you can do that, but that's fine. Okay, and surface area. So surface area. So system is going to be the same, almost the same print line. Dot out. Dot print line. Okay, how about SA for surface area? Equals, quote, plus foo dot get SA plus, quote, nope, quote, yeah, inches squared. Inches squared. Okay, that sounds good. All right, let's calculate the surface area. Now, the lateral surface area we found out was pi r L. L would be the hypotenuse of the cross section of the right triangle that includes the height and the radius of the cone, right? And so that would be r square root of r squared plus h squared. Or you could do r, Math.POw r comma 2 plus Math.POw h comma 2. You could get really crazy with this, but we did Math.sqrt of r times r plus h times h. All right, so let's write that down. All right, so this is saved. Good. Let's go to move this up a little bit. All right, so get surface area, or get SA, public or not, public. Void or not, it's an accessor returns a double. Get SA, and we're going to return, just like we Googled this up. What is it? It's Math.PI times R times L, and L is defined as the hypotenuse of that right triangle that includes the height and the radius of the cone, the base of the cone. So that's going to be math dot squirt, the square root function of the quantity r squared plus h squared. You could do a Math.POW r comma 2 and Math plus Math.POW h comma 2 if you want, but this is less typing, so why not just do this? All right, let's save that. And let's test it. And we got 33.836-ish square inches, right? Yeah, I think that was fine. If you want to space out that the inch part thing, the units, put a little space here, put a little space here. I guess we really don't need a period. Get rid of the period. Put a space here, put a space here. Okay, save that. Alrighty. And what do I do? Where's my Java line? And if that's better to, more legible, that's fine, right? Okay. The only other thing is we should do some Java doc. All right, so let's see the constructors. Where is the constructor? Okay, so all right, so double star, remember? There you go. Okay, so this is a constructor. Alrighty. Let's see, where did I put those stuff? Did we do java.lang in class? We did. All right, this is have a precondition or at param or both. How about an at param? In fact, two at params. At param r is the radius of the cone in inches. Okay. At param h is the height of the cone in inches. Perfect. Okay, now, is there a postcondition or at return? Postcondition is we've instantiated the IceCreamCone object. In other words, we initialized R and H, right? So postcondition. Instantiated an IceCreamCone object. Object. Okay, good. All right, let's go back to, all right, let's go and do the Java doc for get H. All right, so this is a constructor accessor mutator. These are all accesses from now on, right? Okay, is there an at param? Let's see what we got here. Nope, no at param, no parameter list. So how about precondition? The IceCreamCone object has been instantiated. Okay. Let's just say instantiated. Save some space there. Okay, so now what does this have? This has an at return, right? Okay, so postcondition or at return or both is necessary. How about an at return? Return. Okay, so what are we returning? The height of the cone. The height of the cone. Okay. And you can finish off the Java doc, right? So what would you say here? Accessor, precondition, forget our precondition, IceCreamCone object is instantiated. At return, the height of the cone. Okay, we're going to say forget V. We could even say at return the height of the cone in inches, at return the radius of the cone in inches. The only difference with get V is at return the volume of the cone in cubic inches, and for get SA, at return the volume of the surface area of the cone in square inches. So you can finish that off on your own. So there's the whole class, and we call this an immutable class because there's no mutator or modifier methods. And there's your, whoops, save that. There's your tester. That's basically the whole thing right there, except for the header comments. There you go. There's your header comments. Very nice. But that's the whole main class, main method, whatever you want to call it. There it is. And just let's Java see it one more time, just make sure I didn't mess up anything by putting in the Java doc. And it's still good. Okay, good. Thank you, YouTube. Have a nice day. That was fun. Hope that helps.